children, look at the ninth question. If you observe carefully, you could understand this, you can find out from which chapter you have got this question. So take a pause, read the question 2 times. So why I am telling like this is that for physics, first of all, we have to understand the question. We have to understand its terminology carefully. And then we have to recollect from which chapter, from which topic, from which subtopic, and thereafter we can apply the formula. Okay. So take a pause and read the question for 2 to 3 times. Now, a metallic rod of length is rotated with the angular speed. Okay, so angular speed is given, and again magnetic field is given. So what he's saying is that induced EMF. So children, we know that the direct formula induced EMF is given as BLV. This is what is the induced EMF formula. Induced EMF formula. Okay, so we got this from induced EMF E is equal to B BLV, or you could write it as BVL. Okay. So here angular velocity omega is given. So why don't you write this as omega is equal to V into R, or V into omega into R, or omega into X. Okay. Next. So I'm just taking this rod here. Okay. I'm taking it separately, this rod here. So let me say that I'm interested to find out some particular point. This is particular point where the distance of this point from the center. Distance of this point from this center. So this is O. Center O is taken as X, where the length of this small element is dx. Okay. So V is equal to omega into X. We could take like this, where the length of this element is dx. We could say small length, no, so dl. So how to write this formula? So EMF, the small EMF is dE, because we are finding out EMF due to this dx, so you get only small EMF, that is dA. So dA is equal to B, okay. B, in place of V, I'll write it as omega X in place of V. In place of L, I have to take small n dl. So here dl is nothing but dx. So like this, I got the formula for EMF, small EMF. Okay. So apply integration. Apply integration. So that is integral of dE is equal to integral of B omega X dx. So here we are performing integration with respect to dx. So only x must be inside the integration. Clear? So B omega is coming out now. Integral of x dx. So can be written as, where this x is varying from 0 to L. So now this can be written as B omega x square by 2, that is 0 to L. So B omega L square by 2, where integral of d is nothing but e. So I could write it as e. So finally what I could say is that the formula for induced EMF is half B omega into L square. So this is what the relation we get. So you can find that option as 3. So option 3 is correct. Option 3 is correct. So the answer for this question is option 3. So with this we have done with 9th question. Now let us move on to the next one.